Hello friends, welcome to chemistry classes by Vijay Kumar Sethi, class 11th chemistry, and now we will start unit 8 redox reaction. And in this video we will discuss about classical idea of oxidation and reduction reactions. Now with the help of this table we can understand what is oxidation and what is reduction. First come to the oxidation. Oxidation is addition of oxygen, like magnesium plus O2 gives magnesium oxide. So we can say magnesium is oxidized in this reaction. Another example is CH4, methane. When react with the oxygen, it forms CO2 and H2O. Now if you see this reaction, this CH4 is converting into CO2. We can say oxygen is added to the carbon, so this methane is oxidized. Clear? Now this reaction can also be seen in the another way. If you say CH4 is converting into CO2, it means hydrogen is removed from the carbon. Okay, so we can also define the oxidation as a removal of hydrogen. And another example of this removal of hydrogen is this H2S. When react with the O2, this will convert into sulfur and water. This H2S converting into S, hydrogen is removed. We can extend this idea to addition of electronegative element. Actually oxygen is the electronegative element. So not only oxygen, if any electronegative element is added, then that reaction is known as oxidation. For example, when magnesium react with the F2, this will convert into MgF2. Now we have discussed the removal of hydrogen, and in comparison to oxygen, hydrogen is an electropositive element. So we can extend this idea to removal of electropositive elements is also known as oxidation. See this reaction. This is K4FeCN6. When added to H2O2, this will convert into K3FeCN6 plus 2KOH. Now from this K4 in the product, this is K3. Potassium is removed, and potassium is an electropositive element. So in this reaction, this K4FeCN6 is oxidized to K3FeCN6. Clear? Now come to the reduction. Removal of oxygen is called reduction. See this reaction, HgO when heated converting into Hg plus O2. From this to this, oxygen is removed. So we can say HgO is reduced. We can also define the reduction in terms of addition of hydrogen. See this is CH2, double bond CH2. When this react with the H2, this will convert into CH3CH3. This is alkene. On addition of hydrogen, this will convert into alkane. We can also extend this definition of reduction to removal of electronegative element. Okay, like see FeCl3 plus H2 converting into FeCl2 plus 2HCl. Now this FeCl3 is converting into FeCl2. Chlorine is removed, and chlorine is an electronegative element. Another definition of reduction is addition of electropositive elements. See HgCl2 converting into SnCl2, HgCl2 react with the SnCl2, and this will convert into Hg2Cl2 plus SnCl4. Okay, now in this case, this HgCl2, this is converting into Hg2Cl2. Hg is added, okay, and metal. Hg is a metal electropositive element. Okay, now if you see this reaction carefully, then in this case this SnCl2 is converting into SnCl4, and that is chlorine is increased. Chlorine is electronegative element, so SnCl2 is oxidized. So we can conclude that oxidation and reduction reactions taking place simultaneously. So these reactions are known as redox reactions. Reactions in which oxidation and reduction occur simultaneously are known as redox reactions. Okay, every reaction you can see, when oxidation is there, reduction will be there. Okay, just see this first reaction, Mg plus O2 converting into MgO. In this case you can say this magnesium is added with the oxygen, so magnesium is oxidized, but this oxygen is added with the magnesium, so we can say this oxygen is reduced. Okay, now see one problem 8.1. In the reactions given below, identify the species undergoing oxidation and reduction. This H2S plus Cl2 converting into 2HCl plus S. Okay, now just see, first come to this H2S. H2S is converting into S. Okay, what is the change taking place? We can say that is hydrogen is removed. Hydrogen is removed, and removal of hydrogen is oxidation. Okay, so H2S is oxidized. Or you can also see that is in this case two hydrogen chlorine is added, and chlorine is more electronegative atom. So we can say this H2S is oxidized. So H2S is oxidized because a more electronegative element chlorine is added to hydrogen, or we can say hydrogen has been removed from to form sulfur. So chlorine is reduced due to addition of hydrogen to it. Another example is Fe3O4 converting react with the aluminium to convert into Fe plus Al2O3. Now just see what are the changes taking place. In this case, this aluminium is converting into Al2O3. Oxygen is added, so we can say aluminium is oxidized, and this Fe3O4 is converting into this Fe. Oxygen is removed, so ferrous ferric oxide, Fe3O4. Okay, actually this Fe3O4, this is a mixed oxide, and this is ferrous oxide, and this is ferric oxide, Fe2O3. Okay, and both will combine, then we will get Fe3O4, and this is reduced because oxygen has been removed from it. Now Na plus H2 converting into NaH. Now in this reaction it is very difficult to find out which is oxidized and reduced, but if we carefully examine the electronegativity of the elements, then we can find out which is oxidized and which is reduced. Okay, so sodium is a electropositive element and hydrogen is a electronegative element. Hydrogen is added to sodium. Addition of electronegative element is oxidation, so we can say sodium is oxidized. And same reaction can be visualized in terms of sodium is added to the hydrogen, and sodium is electropositive element, so we can say hydrogen is reduced. Addition of electropositive element is reduction. Okay, so this third reaction prompts to think in terms of another way to define the redox reactions. Okay, because if we consider only addition of hydrogen and addition of oxygen or electronegative element or electropositive element, it is very difficult to find out which substance is oxidized and reduced. So there is the another way, and what is this another way? This we will discuss in the next video. Thank you. Subscribe my channel to get the next video from this chapter.